one of the things that changed for me about the entire topic of mathematics was when I realized that all the formulas that we were being given, there was a reason that we had those formulas. And when I learned how to solve for the formulas, or how to develop the formulas or prove the formulas, all of a sudden everything in mathematics began to make sense. I had a teacher in high school that helped me understand the quadratic formula. Now, I had used the quadratic formula many times, but it was just something, it was a plug and chug. If you had ax squared plus bx plus c, you just plugged those into the a, b, and c here, and you got your solutions. But I had no idea where it came from. I just knew that you used it. And then one day in class, the teacher said, well, let's see where that came from. And so we're just going to start with this equation. And we're going to use something called completing the square, that if you've not ever used that, I don't know if I haven't made a video on that one yet, but I'll do a video on completing the square. We're going to use that as a way to solve this equation. So we're going to begin with this equation, and we're going to subtract c from both sides. That gives us ax squared plus bx is equal to a negative c. Now, here's where we're going to divide everything by a. So we want to get rid of the coefficient here, the leading coefficient. So we have to divide every term by a. That gives us x squared plus b over ax equal to a negative c over a. Now, here's where we're going to complete the square. And all we're going to do with that is we want to get a binomial squared equal to something so that we can take the square root of both sides. So all we're going to do is we're going to take half of this, which gives us b over 2a. We're going to square it and make that our third term. That gives us b squared over 4a squared. But you can't just add that into an equation. But if we're going to add it on this side of the equation, we can add it to this side of the equation, and it keeps everything equal. So we're going to say plus b squared over 4a squared. Now we have a perfect square here, so we can rewrite this as x plus b over 2a squared, that's what this factors out to be, is equal to negative c over a plus b squared over 4a squared. Now, just so we can combine these, we're going to multiply top and bottom here by 4a, and that'll give us a 4a squared down here. So this term is going to become 4ac over 4a squared plus b squared over 4a squared. So now we can combine these. So let's move it over here. That gives us then x plus b over 2a squared is equal to negative 4ac plus b squared all over 4a squared. Now, we're going to take the square root of both sides here. That's going to give us x plus b over 2a is equal to plus or minus, because we're taking the square root of, I'm going to switch these around, b squared minus 4ac, just so we have a positive term here. Now we can take the square root of this, so that's going to put it over 2a. Let's subtract this b over 2a to the other side, and we get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. We've got a common denominator here, so we can combine them, and that gives us x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we're actually, this doesn't just come out of nowhere. We're using math to go ahead and find a generic way to find solutions for x in a way that's going to fit everything. So even if you decided not to, if it's easily factorable, you can still use the quadratic formula and just plug the numbers in, and you're still going to come up with the right answers. It's just usually easier to factor. But if you couldn't figure out or couldn't remember on a test what the quadratic formula was, you could actually go through this process with any problem and you would still come up with the same answer.